Let's consider a restrained beams for sample problem number 3. So for this restrained beams, meron tayong inner support na roller at a distance of 4 meter from C. So this beam supports two uniform load having an intensity of 37.5 and 75 kilonewton per meter. And on the span AB, meron tayo dito na concentrated load having an intensity of 100 kilonewton. So for this problem, determine the end moments at the supports using the slope deflection method for the loading shown and a settlement of 8 mm at support B. So for this one, sinabi dito sa problem na meron daw tayong 8 mm na settlement sa support B. So for this one, instead na nandito yung support natin, so meron tayong settlement dito na equal to 8 mm. So exage lang natin, no? So exage lang natin yung details para makita natin yung settlement natin. So yung value ng delta natin dyan is equals to 8 mm. So for this one, yung mangyayari niyan, yung beam natin, bababa siya dito sa point B natin ng 8 mm. So kung i-draw natin yung elastic curve ng beam natin, so kung dati yung elastic curve niya is, so pag ganito tapos, magsasarado siya doon, o sasarado siya sa point B, ngayon yung mangyayari niyan, since nagkaroon tayo ng settlement, so from this one, at a certain distance, di muna siya magde-deflect kasi nga cantilever. Tapos, magde-deflect siya. Tapos, mangyayari niyan is tataas siya. So, tataas siya dito. Doon pa lang siya magsasara. So, this will now become our new elastic curve due to the settlement of 8 mm. So, yung hahanapin lang naman natin dito is the value ng mga end moments natin. So for this one, may mga reactions tayo dito. Reactions sa A, B, at saka C. Tapos may mga moment tayo na reactions at point A at saka point C. So same application lang naman yung gagamitin natin. So for the first step, we're going to calculate for the FEM. So first, we will just consider yung span AB natin. So for the span AB, so we have, so meron tayo sa span AB. So yung buong length ng beam natin, so merong naka-apply na 37.5 kilonewton per meter. Tapos meron tayong 100 kilonewton sa gitna. Since ganito lang naman yung ano natin dito, yung length niya 6 meter. Since basic lang naman yung figure natin, so mabilis lang yung pagkuha ng FEM. So for this one, dito sa side na to, we have yung tinatawag nating FEM-BA. And yung sa kabila, we have FEM-AB. So for this one, let us calculate first for the value of your FEM-AB. So we have FEM-AB is equals to, since nasa gitna yan, we can use yung formula natin na PL over 8. Pero kung hindi nyo alam yung formula na yon, we can also use yung formula natin for the concentrated load na PAB squared over L squared. So meron tayong distance dito na 3 meter, tapos sa taas 3 meter. So we have 100 multiplied by 3 squared all over 6 squared plus yung formula natin for this one na WL squared. So yung form W is 37.5 WL squared over 12. The value of your L is 6 squared all over 12. So the value of your FEM-AB is now equal to 187.5 kilonewton meter. And yung rotation niya is counterclockwise. Since obvious naman na symmetrical yung dalawa, so meaning to say the value of your FEMAB and the value of your FEMBA is parehas lang yung value nila. So the value of your FEMBA, that is equal to 187.5 kilonewton meter clockwise. So next naman, we're going to consider yung span BC natin. So for the span BC, sobrang dali lang kasi nga yung mangyayari is meron lang tayong isang uniformly distributed load na merong intensity na 75 kilonewton. Kilonewton per meter. Yung length niya, that is equal to 4 meter. So we have yung point B and C. So siyempre, we will have a fixed end moment dito na BC. This is FEMBC. And also sa kabila natin, that is what we call FEMCB. So for this one, since symmetrical lang naman yung loading natin, that's why yung value ng FEMBC equal lang siya sa value ng FEMCB. So for the value of your FEMBC, since it is a uniformly acting on full length of our span, so that will become W L squared over 12. So your value of your FEM is now equal to 100 kilonewton meter. So counterclockwise. Therefore, the value of your FEMCB is equals to 100 kilonewton meter. Rotation is clockwise. So for this one, after computing for the value of your FEM, since meron tayong settlement ng support natin dun sa internal, so we will going to calculate yung rotational displacement. So for the rotational displacement, ito yung tinatawag natin na symbol na psi. So yung psi natin is equals to delta over L. So for this one, we will going to consider yung beam natin that has a settlement of 8 mm. So for this example, we will going to consider yung rotational displacement natin caused by the settlement of 8 mm dito sa support B natin. So for this one, yung mangyayari niyan, so meron tayong vertical displacement dito which is equal to 8 mm, or in meter, we have a value of 0.008 meter. So this will now become the value of your new B prime. So ito na yung bagong location ng support B natin. So if you were going to illustrate, no, magkakaroon tayo dyan ng rotational displacement. Hahanapin natin yung value ng rotational displacement natin. So for this one, ito yung magsisilbing rotational displacement natin. So ibig sabihin lang naman ng rotational displacement, ano yung angular displacement natin nung nagkaroon tayo ng 0.008 meter na settlement. So for this one, yung tinatawag nating rotational displacement dito is this one. So ito yung angle natin, which is ito yung psi AB. So lagi yung angle natin with respect to the horizontal. So for this one naman, with respect to the horizontal, so makukuha naman natin yung psi BA natin. So by since alternating angles yung mga yan, so therefore we can conclude that the value of your psi AB is equal siya sa psi BA. So for this one, kaya na-calculate yan kasi nga, so we have a value para makuha natin yung value ng tangent. Tangent psi AB is equals to opposite. So that is delta all over yung L natin dito. So, opposite over yung length natin. Since sobrang iliit lang ng sine AB natin, so yung tendency, in-approximately equal na lang siya sa sine AB is equals to delta over L. So, for this one, kung meron tayong rotational displacement sa AB at saka sa BA, siyempre, meron din tayong rotational displacement dito sa CB at saka BC. So for this one, ito naman yung location ng rotational displacement natin sa CB. Ito yung tinatawag nating sine CB. Tapos dito naman, meron tayong tinatawag dyan na rotational displacement from B to C. So let's solve for the value of our rotational displacement. So for this one, so for the span AB, so we have yung sine AB at saka yung sine BA, that is equal to yung delta natin, which is equal to 0.008 all over yung length natin. So that is yung distance natin, which is yung length natin dito is equals to 6 meter. And yung kabila naman, that is equal to 4 meter. So for this one, that is equal to 6. So yung value ng angular displacement, yung rotational displacement natin is 1 over 750 radians. And yung rotation niya is counterclockwise. So counterclockwise. So next, yung sine BC natin is equal siya sa sine CB, which is equal to the displacement or the settlement all over yung length natin, which is equal to 4. So the value is we have 1 over 500 radians. And yung rotation naman is counterclockwise. So for this one, so we can proceed for the step letter C natin in computing for our slope, deflection equations. So for this one, meron tayong value ng rotational displacement natin. Hindi katulad sa mga ginagawa natin sa mga previous examples natin. So for this one, we can now calculate. So let's consider span AD. So we have yung MAB natin. So that is equal to 2EI over yung L natin na 6. So 2 theta A plus theta B minus 3. Tapos multiplied natin yung sine natin, which is equal to 1 over 70. Since it is clockwise, kaya positive yung value ng sine natin, plus yung value ng FEM natin, which is yung FEM natin dito, since it is counterclockwise, kaya yung value niya is equals to negative 187.5. So if we were going to further simplify yung equation natin, so we will have 2EI theta A over 3 plus EI theta B all over 3 and minus EI over 750 minus 187.5. So this will now become your equation number 1. Next, let's solve for the value of your MBA, which is equal to 2EI 2 theta B so the value ng ano natin, FEM natin dito, since clockwise, so that will become positive 187.5. So the value of your MBA, kung isi-simplify natin siya, so we will have, so MBA is equals to 2EI theta B all over 3 plus EI theta A all over 3 minus EI over 750 plus 187.5. So this will now become our equation number 2. So next naman, we're going to consider yung span BC natin para makuha natin yung value or yung equations ng mga moments natin. So ganun lang naman, same procedure lang tayo. Kaso nangyari lang is meron lang tayong rotational displacement na in-include dun sa formula natin. So let us continue considering yung span BC natin. So for this one, we have yung span BC natin. So the value of your MBC, that is equal to 2EI over yung length natin na 4. So we have 2 theta B minus 3 multiplied by, so yung rotational displacement natin dito, that is equal to negative 1 over 500. Kasi nga yung rotation natin is counterclockwise. So minus the value of your FEM, since it is counterclockwise kaya negative minus 100. So kung i-arrange natin yan, so we will have, so we have EI theta B plus EI theta C over 2 plus 3EI over 1,000 minus 100. So this will now become your equation number 3. So next naman is for the value of your MCB. So 2EI over 4. So yung 2 theta C plus theta B minus 3 negative 1 over 500 plus naman yung value ng 100 natin. So the value of your MCB is now equal to, so we have EI theta C plus EI theta B all over 2 plus 3EI over 1,000 plus 100. So this will now become your equation number 4. So after computing sa mga natin, sa mga slope deflection equations natin, so we can now move sa mga joint conditions natin. So for this, we will going to apply yung next step natin sa mga joint conditions. So after that, sa mga joint conditions natin, dun natin makukuha yung value ng mga slopes natin. And then, substitute natin yung value ng mga slopes natin, makukuha natin yung mga values ng end moments natin. So, let's solve. So, joint conditions muna tayo. So, yung joint A natin, at joint A, so yung value ng theta at A natin dyan is equal to 0. So, from that, we can simplify yung equations 1 at saka equations 2 natin. So, yung mangyayari niyan, magwala ng value yung theta E natin. So, yung equation natin for MBA, so, yung value natin for this one, sa mga theta E natin dito, is equal to 0. So, this one, 0 na din siya. So, mangyayari niyan is liliit yung equation natin sa 1. So, the value of your MAB is equal to EI theta B all over 3 minus EI over 750 minus 187.5 So that will become your equation number 5. Next naman is yung MBA naman natin. So, rewrite lang natin yung equation natin. So, that will become 2EI theta B over 3 minus EI over 750 plus 187.5. So, this will now become your equation number 6. So, after joint A, meron tayong joint D. So, for the joint B pala, so since it is an internal support, so the value of your MBA plus MBC is equals to 0. So kung gagamitin natin, kung ilalagay natin yung mga values natin na yan, so we will have so for this one pala, no, huwag muna natin i-consider yung joint B natin. Kasi mangyayari, dito sa joint C, meron tayong, yung joint C muna yung consider natin. So, joint C, so yung value ng theta C natin dyan is equal to 0 since fixed yung support natin. So, for that one, yung mangyayari niya dito sa equations 3 at saka 4 natin, mamamodify siya. So, yung theta C natin, this is equal to 0. Ano pa? Yung EI theta C natin, that is equal to 0. So, mangyayari niyan is we have a new value for MBC. So, MBC is now equal to, so, write lang natin, plus 3EI over 1,000 minus 100. So, that will become your equation number 7. So, susunod naman for the value of your MCB, that is equal to, so mawawala to. So, we have EI theta C over 2 plus 3EI over 1,000 plus 100. So, this will now become your equation number 8. So, for this one, let us apply lastly sa joint B natin. Wherein yung MBA plus yung MBC natin, that is equal to 0. So, gamitin natin yung sa MBA natin. So, etong equation 6 natin. So, we will have 2EI theta B over 3 minus EI over 750 plus 187.5 plus the value of your MBC na EI theta B plus 3EI over 1,000 minus 100 is equals to 0. So, kung aayusin natin yan, so we will have ayusin natin etong theta B natin, tsaka theta B natin, pagsamahan natin sila. So, we will have 5EI theta B all over 3 plus EI over 600 is equals to, so 187.5 minus 100. So, we have 87.5. Transpose natin, magiging negative 87.5. So, na-simplify na yung value ng mga formulas natin. So, dito pala sa problems natin. So, nakalimutan ko lang. So, for this one, ito na yung pinaka-simplified natin na value ng mga formulas natin. So, dito na tayo nag-arrive sa equations natin. So, meron na lang tayong isang unknown dito. So, yung unknowns natin dito is eto na lang, theta B. Kasi yung value ng EI natin, already given na yan. So, nakalimutan ko lang isulat. So, the value of your E, based dito sa problem natin, is equal to 200. So that is equal to 200 gigapascal. And the value of your I is 213 times 10 raised to 6 millimeter to the fourth. So meron na tayong value ng EI natin. So if you will going to solve for the value of your EI in terms of kilonewton meter squared, so pag multiply lang natin yung EI natin. So yung EI natin, that will become 200 times 10 raised to 9. So imumultiply natin yan sa 2.13 kasi gagawin natin tong meter squared. So times 10 raised to negative 4 is equal to 426 times 10 raised to 5 kilonewton meter squared. Or in other words, gawin ninyo yung lahat ng paraan para maging kilonewton meter squared siya. So since yan na yung value natin. So for this one, so we have 200 times 10 raised to 9 times 2.13 times 10 raised to negative 4. So that is equals to 426 times 10 raised to 5 kilonewton cubic meter. Cubic squared. So kung i-substitute natin yung value natin na to with respect dito, so mangyayari niyan, we will going to substitute this one dito sa equation natin. Makukuha natin yung value ng EI theta B natin. So for this one, since given ang EI natin, madali na lang siyang isolve. So for this one, yung gagawin natin is kunin na lang natin yung value ng EI theta B natin. Kasi ito naman yung nasa mga formulas natin. Kasi in terms of EI theta B yan. So kung kukunin natin yung EI theta B natin, so kapag sinip-solve natin yan, may values tong EI natin. For this one, huwag kang maglagay ng value for the EI theta B mo. So gawin mo is, lagay mo tong X sa calculator. So yung EI theta B natin, yung kailangan natin, hindi yung theta B. So for this one, the value of your EI theta B is equal to negative 42,652.5 kilonewton meter squared. Since it is negative, yung rotation niya is counterclockwise. So kung isa-substitute natin yung values natin sa mga equations natin dito, so mangyayari niyan, so the value of your MAB here, so for this one, makukuha na natin yung value ng MAB natin. So substitute mo lang yung value ng EI natin. So for the MAB, we have negative 71,205 kilonewton meter. And for the BA naman, we have negative 85,047.5 kilonewton meter. I-substitute mo lang yung value ng EI natin and the value of your EI theta B. So same with the MBC naman. So for the MBC, we have positive 85,047.5. And lastly, for CB, we have 106,573.75. So ganun lang yung procedure natin kapag meron tayong settlement sa support.